Alright guys, in the last video we were talking about direct and inverse proportional direct and inverse proportions, and there was one little thing that I made a slight little mistake on. Don't worry, if you were watching the last video, 99.9% of that video is accurate. There is one little mistake, one little subtlety, and I'm going to go ahead and go through and show you just a different way of solving, just so that you're 100% clear what I was talking about. Okay, so let's recap. Last video we were talking about direct and inverse, and I showed you how to solve it, and then I said there's another approach to this involving y equals kx. Don't use that, use what I taught you, okay? So here we go. So this is what we did last time. We said 3 over 2 equals 9 over 6, and we just cross multiplied and we solved, and we got y to be 6, or rather 3 over 2 equals 9 over y, cross multiplied and solved, okay? All that this formula is saying is, given our x and y values, and if I recall correctly, x is 3, y is 2. So if I plug into the formula, it would be x is 3, y is 2, as such, given x is 3 and y is 2. Okay? So if we solve this, we end up getting k to be 2/3. Okay? So the way this method works is, given this formula, then once I figure out what k is, if given that in the second part where they tell us that x is 9, what is y? The way that this works is you just substitute in the values again. So y equals k is 2/3 and x is 9, and then I solve this. Okay, so 3 goes into 9 3 times, 2 times 3 is 6, and you get the same exact answer. Okay? My mistake last time is what k represents. Okay? What k represents, it does not represent what I had said last time. So what I said last time was that it represents this times 3 fact. Okay? It doesn't represent that. What it represents is the division of these values. Okay? Now, why is it that this says 3 over 2 and over here k is 2 over 3? Well, that's because if we look at this, I'm writing it as x is 3 and y is 2, right? Okay? Well, notice something here. If I solve just this for k, it would be k equals y over x, right? And what do I have here? I have x over y. So note that if I flip it, the word for flipping in math is reciprocal. So if I take the reciprocal, I find k, find this constant. And if you look at this, whether you do 3 over 2 or 2 over 3, this still stays the same. So whether I'm saying 2 over 3 or 6 over 9 or 3 over 2 and 9 over 6, notice 9 over 6 reduces to what? 3 over 2. Or if I flipped it and said 6 over 9, what would that reduce to? 2 over 3. It becomes the same thing. So this k value is what happens when you divide. The other version would be if it's inverse, right? Which is y equals k over x. Okay? So let's look at this situation here. Now, I can't remember what I called x and y from this, but let's just say that this is x and this is y, and that this is x and that this is y, right? So let's look at what happens here if I multiply both sides by x. I would get x times y equals k. Okay? So here k represents the multiplication of any two values. So it's pretty obvious 10 times 40 is going to be equivalent to 40 times 10, right? But what if I say that another set of values are inversely proportional? Let's say I give you 10 to 40, and just to make sure that everything stays kind of clear, let's say that the other one is going to be 400, right? And I want to figure out what this value is, and we'll call this y, okay? So if I use this relationship that we used last time, it would be 10 times 40 equals 400 times y, right? Okay? And if I solve this, I divide through by 400, and I divide through by 400. I'm going to end up getting, look what's going to happen here. If I multiply 10 times 40, I'd actually get 400. So this is just simply going to become 1, and y is 1. Okay? So what does that mean? So if I look back here, if I reset this up, this is going to be 10 times 40 equals 400 times 1. Okay? Again, notice what happens here. K has to be the same. This is why we're setting these equal. So 10 times 40, which is 400, has to be equal to 400 times what? It has to be equal to 400 times 1. Okay? So maybe, hopefully that this gives you a little bit better perspective of actually what goes on between direct and inverse. You don't have to set these problems up using y equals kx and y equals k over x. This is the way it's usually taught in high schools, but I actually think the way I showed you in the previous video is infinitely easier, and hopefully this video shows you that it is. But this does give us more of an idea of what it means to be direct and what it means to be inverse. Okay? All right, well, I'll see you in the next video.